Welcome everyone to the part 2 of my mini video series of how to make a tip calculator app. Now that we have seen how the layout is structured, let's explore the actual logic that makes the tip calculator useful. We'll go through three main parts. First, the tip calculate function, then the edit number field composable, and finally, the round the tip row composable. Well, here's the calculateTip function. It takes three parameters. First, the amount, that is the bill amount as a double. Then we have the tip percent, the percentage to tip. And finally, the roundup, that is a boolean flag. The calculation itself is simple. It is tip percent between 100 by amount. If roundup is true, we apply sale to round it up. For example, let's say if the bill is 87.50 and tip percent is 18, the round tip is 15.75. If we round up, it becomes 16. Finally, the function returns the tip formatted with NumberFormat that getCurrency instance. This makes it appear as 15.75 or 16 depending on rounding. Using NumberFormat is powerful, and you will ask yourself why? Well, because it automatically uses the right currency symbol based on the phone's locale. If the phone is set to euros, it shows as a euros. If it's yen, it shows yen. That's internationalization for free. Now let's talk about the text fields where users type values. Instead of directly using text field everywhere, the app defines a custom composable called edit number field. This composable accepts four main things. First, a label, like bill amount. Second, a keyboard option to control the input type. Then the third one, the current value, and last one, an onValue change lambda to update state when the user types. Inside, it just calls text field, but wrapping it in a function makes the code cleaner and reusable. The keyboard options are especially important. For bill amount, the action is next, so pressing enter jumps to the next field, and for tip percentage, it's done. So pressing enter closes the keyboard. And since we use keyboard type .number, the numeric appears automatically, making it faster for the user to input numbers. The last piece is the round-the-tip row function. This is a simple row with a label and a switch. The switch is connected to the roundup state variable. When the user toggles it immediately calls roundup change, which updates the state. Because compose is reactive, the moment the state changes, the calculateTip function is re-executed and the tip text updates instantly. And there's no need for manual listeners or observers. The framework handles it. So, putting, putting it all together, first, the user enters a bill amount and percentage. Then the app calculates the tip using a simple formula, as I said before. Then, if it's round on, it rounds up. And then the result is displayed in proper currency format. What is really nice here is how clean and modern the Compose code looks. Because in older Android development, we'd need XML layouts like find view by ID function, text change listeners, and so on and so on. With Compose, everything is in one place, reactive and easy to read. And this project is just a start because you can expand it by adding a split bill option for multiple people, then letting users pick from a drop-down of common tip percentages, or even building a dark mode toggle. So Thank you for watching, and I hope this step-by-step breakdown helps you to understand not just how this app works, but also how Compose makes UI development much simpler and more enjoyable.